Welcome back to QHSE Talks, the show where we go beneath the surface of safety, not just to talk about rules and checklists, but to uncover the why behind them. Because in the real world, safety isn't paperwork. It's systems, it's design, it's people making decisions under pressure, and the consequences of those decisions can define entire industries. Now, if you've ever been in the world of HSE or engineering, you've probably heard the three letters that carry serious weight. CSP, the Certified Safety Professional. It's more than a credential, it's like a map of the entire safety universe. You can't earn it without understanding how engineering meets risk, how human behavior meets management systems, and how laws and science shape every decision we make on a job site or in a control room. See, the CSP isn't just about knowing safety, it's about thinking safety. It's proof that you can connect theory to reality, that you can translate dense technical knowledge into real-world protection for people, property, and the planet. It's the ultimate benchmark, the title that says, I don't just follow standards, I understand the science behind them. And that's what we're diving into today. Not just what the CSP exam covers, but the bigger picture it represents. Because when you start looking at what's inside that certification, you start to see the entire structure of safety science itself, how it's built, and how it keeps evolving with technology, complexity, and global risk.
Okay, let's maybe start from the ground up then. We often think of engineers just as, builders. People making things.
Sure, creators of structures, machines.
But the source material we looked at makes it really clear that the engineer's role in public safety is absolutely fundamental. It's historic, and it's getting more complex all the time.
Yeah, it really is. It's about tackling the inherent risks that come with modern technology, The products, the systems, even the waste streams they generate. Society relies on engineers to manage that.
So it's not just about making something work.
That's the critical distinction, exactly. A functional system isn't necessarily a safe system. And you see programs like the National Safety Council's Institute for Safety through Design. Their whole goal is to elevate safety.
Elevate it how?
From being an afterthought, something you bolt on at the end, to being a core design principle. Baking safety into the design of products, processes, equipment, vehicles, right from the absolute start, conception.
That feels like a real paradigm shift. Like, if you make a car that's super economical and fast, but it crumples in a crash,
failed
the most important test.
Yeah. You've fundamentally failed.
Yeah.
Yes. And that means the expertise required is just immense. But also, and this is just as critical, the professional humility needs to be there too.
Humility? How so?
Knowing your limits. Honestly, the most important skill for anyone in this field, engineer, manager, anyone, is knowing when to stop and say, okay, I don't know the answer here. I need other expertise.
Recognizing the boundaries of your own knowledge.
Exactly. You have to manage trade-offs all the time. Cost, convenience, risk. It's a constant balancing act. But that balance requires recognizing when a potential hazard goes beyond your specific discipline. That's when you need to bring in that specialized safety professional, the one who holds that synthesis of knowledge.
And that very distinction, knowing when to call in the expert, that leads us straight to the credential we're focusing on today, the CSP.
It does. That's the person you call. So the expert we're talking about, they're certified by the Board of Certified Safety Professionals, the BCSP. And that CSP designation, it's actually a certification mark issued by the U.S. Patent and Trademark Office to the BCSP.
So it's not like a club membership you just pay for.
Not at all. It's a formal statement of demonstrated measured competence. It means you've passed the tests, you've met the experience requirements, you've proven it.
And what really gets me about the CSP is just the sheer range of where they operate.
Yeah.
It's almost dizzying. It's not just one niche industry.
Oh, you're absolutely right. It's practically the entire industrial landscape. They are absolutely essential risk managers across, all the major sectors you can think of.
Like
huge petroleum and petrochemical operations, heavy manufacturing, complex construction projects, think skyscrapers, bridges, healthcare systems, with all their unique biological and ergonomic risks.
Even insurance?
Even the insurance industry, yeah. They often work as loss control consultants, helping businesses reduce their risks before something happens. A CSP is frequently the lead person for comprehensive safety, health, and environmental programs. Sometimes they're managing risks for organizations with, 1,000 or more employees, often globally.
Wow. Okay, so if the CSP is the absolute pinnacle, the person synthesizing all that risk. What's the first step? How do you start climbing that ladder?
That first major step, the entry point onto the certification path, is the Associate Safety Professional, or ASP.
ASP.
Getting that ASP designation is the first full certification milestone. It signals that the individual has already met specific academic requirements, the prerequisites, and they've passed the first big exam, the Safety Fundamentals examination.
So the ASP is already a certified professional, just maybe the step before the full CSP.
Think of the ASP as maybe the highly competent field supervisor or a key safety specialist. They're the ones who can effectively implement the strategic safety policies that might be developed at the CSP level. They're deeply involved in the day-to-day safety functions.
And their duties are already way beyond just like basic compliance checking, right?
Right.
They sound like the frontline defense.
Oh, definitely. Their responsibilities are focused heavily on continuous assessment and the immediate control of risk. This means things like making systematic worksite assessments, going out, identifying risks, potential hazards, and figuring out the right controls to mitigate them proactively.
Not just waiting for an accident.
Exactly. And they're also responsible for evaluating how well those hazard controls are actually working. Did the machine guard function as intended? Did the training actually change behavior? Did the new procedure prevent the potential error?
So it's not just ticking a box, like you said. It's checking the result of ticking the box, making sure it worked.
Precisely. Outcome focused. They're also often the investigators when things do go wrong, maintaining and evaluating loss records, digging into incidents to find the true root causes, not just the surface symptoms. And yes, ensuring regulatory compliance is part of it too.
What else falls under the ASP?
They're crucial in preparing detailed emergency response plans. What do we if X happens? They need sharp hazard recognition skills, seeing new or changing risks as they emerge, and applying principles like fire protection, ergonomics. That's part of their daily professional level work. They basically translate high-level strategy and policy into tangible, on-the-ground reality.
That makes the ASP sound like a critical translation layer. But you mentioned earlier this whole safety structure in the CSP credential itself. It's built on traditional engineering disciplines, right?
Absolutely. Deep roots there.
So let's connect that professional context back to those foundations. The source material specifically highlighted civil and industrial engineering. How do they fit in?
Okay, let's take civil engineering first. Its contribution to safety is, well, it's profound, but often kind of invisible because we take it for granted. Civil engineers are fundamentally responsible for structural integrity.
Making sure buildings and bridges don't fall down. Pretty basic safety.
Exactly. Their work is public safety in a very literal sense. Modern building codes, you can trace so many of them directly back to catastrophic failures. Each change is basically a safety lesson learned the hard way, written in concrete and steel.
So structural integrity is key. What else for civils?
Well, their responsibility goes way beyond just stability. They're also central to environmental safety. Think about the safe handling, storage, treatment, and crucially, the eventual disposal of industrial and municipal wastes.
Right, because if that's not done safely.
The health risks can be massive, potentially lasting for generations. Contaminated groundwater, soil, it's a huge public health issue. And then there's transportation safety too. Civil engineers contribute heavily there, designing the infrastructure, the facilities, the systems for railroads, highways, ports, airports. They're managing the risks of the built environment on a massive scale.
Okay, so that's the big picture, the infrastructure focus of civil engineering. How does that contrast with industrial engineering? The source material suggested it's microscopic, focused on the human within the system.
That's a really good way to put it. A powerful contrast. Industrial engineers, or IEs, are definitely concerned with optimizing efficiency, but true optimization must include safety. Their core focus is often about fitting the jobs, the equipment, and the work environment to the person doing the task.
So this is where ergonomics comes in, human factors.
Exactly. This is the domain of ergonomics or human factors engineering. It moves beyond just simple mechanical guarding, like putting a fence around a machine. It gets into psychological and physiological risk.
How so? Give me an example.
Okay, well, ensuring that repetitive motions required by a job don't lead to crippling musculoskeletal injuries like carpal tunnel syndrome, or designing a control panel for complex machinery so that it's intuitive, so the operator can't easily activate a dangerous function in the wrong sequence, especially under stress.
It's about designing out the potential for human error.
To a large extent, yes. Industrial engineering integrates human limitations, things like reaction time, fatigue, cognitive load, decision-making biases directly into the system design. The goal is to proactively eliminate pathways to injury. And the safety professional, whether ASP or CSP, absolutely must understand this human-centered approach because, let's face it, most incidents involve some human error component, but that error is often triggered or enabled by poor design.
Okay, so we've established that the safety professional, especially at the CSP level, is operating right at this complex intersection of advanced engineering, human factors, risk management. It's a lot.
It really is.
Okay, let's talk logistics. How do you actually get there? How do you achieve this elite CSP status? You mentioned the BCSP is the credentialing body.
Yes, the Board of Certified Safety Professionals is the sole governing body, and this credential, well, it demands rigorous qualifications and a serious commitment. Like we touched on, getting the CSP involves a dual examination process.
2 exams, not just 1.
2 separate, difficult, highly comprehensive exams. First, you have to pass the Safety Fundamentals examination that gets you the ASP designation we discussed. Only then, after you've accumulated additional specific professional safety experience.
Real-world experience.
Some proven, relevant, real-world experience, yes. Only then are you eligible to even sit for the advanced CSP examination.
So the structure itself seems to insist on both that broad theoretical knowledge and proven application in the field. You can't just be book smart.
That's absolutely the key implication. They require minimum qualifications just to be eligible to sit for either exam. This usually means specific academic degrees, often in safety or related science engineering fields, coupled with that verified professional safety experience. The BCSP isn't certifying recent graduates with no practical background. They're certifying professionals who've already dealt with complex safety challenges out there.
Okay, given the sheer scope of knowledge we're about to map out with these blueprints, the preparation must be intense? This isn't something you cram for over a weekend?
Oh, absolutely not. No way. The complexity, the breadth of the required knowledge base, it really necessitates developing a formal, structured, multi-month examination preparation plan. You have to be strategic about it.
Strategic how?
Well, the goal of studying isn't just memorizing isolated facts. It's about identifying your own personal strengths and, more importantly, your weaknesses across this vast blueprint of topics. You need that self-assessment.
So if you're, say, an experienced industrial hygienist.
Right. You might be really strong on occupational health topics, toxicology, sampling. But you might need to focus heavily on, say, the financial aspects of risk management, or maybe structural engineering principles, or fire protection systems engineering.
Vice versa for an engineer.
Exactly. An engineer might need to drill down hard on epidemiology, toxicology, training methodologies, or safety management theories. These exams, ultimately, they're measuring your ability to synthesize information from different domains and apply it, often under time pressure. It's about demonstrating comprehensive competence.
And that strategic roadmap you mentioned, the blueprint itself, that seems like the most crucial document in this whole process. It literally defines the field, doesn't it?
It really does. It's the curriculum. It defines what a top-tier safety professional needs to know. It's the knowledge map for the world's most advanced safety managers.
Okay, this is where we shift gears. We've defined the role, the path. Now let's define the knowledge.
Yeah.
Looking at these blueprints, you really see that the CSP needs to be a genuine polymath, someone who can synthesize physics, chemistry, advanced statistics, law, management theory, human factors. It's mind-boggling.
It is a vast territory.
So this section isn't just a quick overview. This is basically the definitive roadmap for our next 2 deep dives where we're going to drill right into the technical specifics outlined here.
Exactly. We're laying the foundation now for what will be, frankly, hundreds of hours of learning for anyone pursuing this. So let's start with that base layer. The Associate Safety Professional, the ASP Blueprint. This is what's tested in the Safety Fundamentals exam. ###A. The Associate Safety Professional, ASP Blueprint. The Foundational 7.
Okay, looking at the ASP blueprint, the first thing that leaks out is the weighting. The single biggest chunk isn't a specific technical hazard like fire or chemicals, it's safety management systems at 23%. That's almost a quarter of the exam.
And that weighting tells you everything about modern safety thinking. It fundamentally underscores that safety failures are rarely just a technical fault. More often, they're rooted in organizational or management system failures.
So this domain is about the how safety is organized.
Precisely. It requires understanding the structure of effective safety programs, core management principles, leadership commitment, employee involvement, hazard communication. The whole organizational framework needed for successful, sustainable risk reduction.
Okay. Number 2 in weighting is mathematics at 18%. That tells you quantification is critical right from the start.
Absolutely foundational. Safety isn't just about feelings or intuition, it's a quantifiable science. This domain covers the essential calculations and formulas needed for, well, almost everything.
Like what?
Determining structural loads, calculating required ventilation rates for confined spaces, performing statistical analysis of injury trends, understanding basic probability, calculating noise exposures, the list goes on.
If you can't quantify the risk, you can't measure the effectiveness of your controls.
Right, you need the numbers. Okay, moving into the human side, we've got ergonomics at 13%.
Yes, the human factors domain. Fitting the work to the person. This involves understanding things like physiological stress, biomechanics, how forces affect the body, and designing tasks and workstations to minimize the risk of musculoskeletal disorders, or MSDs.
Those chronic injuries.
Exactly. Carpal tunnel, back injuries, these are incredibly common, high cost, and debilitating. So the ASP needs a solid grounding in ergonomic principles. Okay, then we have a cluster of 3 domains, all tied at 11% each. Let's take occupational health first.
Right, occupational health. This focuses on worker exposure and the fundamentals of occupational illnesses. This is really the ASP's introduction to the core concepts of industrial hygiene.
So, recognizing hazards.
Recognizing hazards, understanding the basic types of hazardous agents, chemical, physical, biological, how they enter the body, inhalation, absorption, ingestion, and the fundamental hierarchy of controls, like substitution, engineering controls, administrative controls, and PPE.
And also at 11% is fire prevention and protection. That's not just knowing where the extinguishers are, I assume.
Definitely not. It's understanding the science behind fire, the basics of the fire, tetrahedron fuel, heat, oxygen, and the uninhibited chemical chain reaction. Understanding the different classes of fire, A, B, C, DK, and which extinguishing agents work for each. Critically, it's about the principles of prevention. Separating fuel and ignition sources, containing hazards, and ensuring early detection systems are in place.
And the third one, at 11%, is training, education, and communication. Why is this weighted equally with fire and health?
Because a technically perfect safety program is absolutely useless if the knowledge isn't effectively transferred to the workforce and doesn't stick. If people don't understand the risks or how to use the controls, the system fails.
So it's about effective teaching.
It requires knowing the principles of learning how adults acquire and retain information best, understanding how to structure training sessions, develop clear objectives, deliver the information effectively, and crucially, how to communicate complex risk information to a diverse workforce to ensure genuine comprehension, not just checking the attendance box.
Wait, I think we skipped one. There are 7 foundational domains. Environmental management, where does that fit?
Yes, good catch. Environmental management. That sits at 15% for the ASP exam.
So more than ergonomics or fire or health.
Yes, which signals that even the foundational safety professional, the ASP, is expected to have a solid grasp of basic environmental stewardship and the key regulatory frameworks. They need to understand how their site's operations impact the environments, air emissions, water discharges, waste generation, and know the basics of compliance to prevent spills, illegal disposal, and environmental harm. It firmly places the ASP within the broader EHS environmental health and safety paradigm right from the start.
Okay, that paints a picture of a really robust foundation for the ASP. Organizational skills, analytical skills via math, core technical knowledge in health, fire, environment, and the human element with ergonomics and training.
It's a comprehensive base.
But now let's look at the climb, the step up to the full certified safety professional, the CSP. The complexity seems to ramp up significantly.
Oh, dramatically. The CSP blueprint reflects that. #tag B. The certified safety professional CSP blueprint, the advanced 9. Yeah, the CSP exam demands a much deeper, more comprehensive level of application, synthesis, and critical decision-making capability. The number of domains actually increases from 7 for the ASP to 9 for the CSP, and the focus shifts towards more specialization, particularly in high-level risk assessment and management strategy.
Okay, let's start with the intellectual toolkit. Advanced sciences and math comes in at just under 10%. 9.95%. This isn't just the basic calculations anymore, is it?
No, definitely not. This is about applying complex technical principles, drawing heavily on physics, chemistry, and advanced statistics. For instance, you might need to calculate the probability of a complex system failing using reliability analysis. Maybe looking at components arranged in series versus parallel and how that affects overall system reliability.
Give me another example. How does, say, physics apply directly?
Okay, think about industrial ventilation. A CSP might need to apply principles of fluid dynamics, like using Bernoulli's principle, which relates the velocity and pressure of a moving fluid, to actually evaluate the effectiveness of a local exhaust ventilation system. Is it capturing contaminants at the source? Is the duct velocity high enough to transport them?
Ah, so that's why knowing things like Torricelli's law, which calculates fluid velocity from tank depth, is relevant. They need to predict flow rates for things like spill response or process safety.
Exactly. It connects the pure science directly to designing or evaluating control measures. And that deep technical capability directly supports the next big domain, management systems, which is weighted even higher here at 13.34%.
How does this CSP level management systems differ from the ASP's foundational knowledge? It sounds similar.
It builds on it, but goes much deeper. This level requires a sophisticated understanding of integrated safety management structures. It's not just knowing an organization needs a safety policy, but knowing how to design and implement a system that embeds safety accountability throughout the entire organizational hierarchy, from the CEO down.
So more strategic.
Much more strategic. It requires knowledge of classical management theories like McGregor's Theory X and Theory Y about employee motivation and how those assumptions impact safety culture. It involves integrating quality management concepts like the Deming cycle, plan, do, check, act, into a framework for continuous safety improvement. It's also about things like ensuring line managers are held accountable for safety performance through formal performance appraisals and using sophisticated cost-benefit analysis and accounting methods to justify safety investments and demonstrate their value to leadership.
Okay, that makes sense. But the core responsibility, the absolute heart of the CSP role,
Yeah.
surely revolves around understanding and controlling risk, right? Dealing with uncertainty.
Absolutely. And that brings us to the highest weighted domains, starting with risk management itself at a significant 14.49%.
Nearly 15%. What does that entail at this advanced level?
Risk management here is the core strategic function. It demands a comprehensive, systematic approach to identifying hazards, assessing the associated risks, prioritizing those risks, developing control strategies, and even understanding how risks are financed, things like insurance, self-insurance, contractual risk transfer.
So looking at risk before and after an event.
Exactly. We look at pre-loss objectives, things like reducing the frequency or severity of losses, segregating risks so one event doesn't cause a total catastrophe, and post-loss objectives like ensuring business continuity, managing claims effectively, fulfilling legal obligations. And the assessment techniques become much more rigorous. We move beyond just subjective observation into hard numbers.
Tell me more about that quantitative approach. You mentioned a hazard risk number.
Yes, the HRN. While qualitative analysis, like using a standard probability consequence matrix, is still important, the CSP needs to be able to apply quantitative analysis techniques. The hazard risk number, or HRN, is a common example. It's typically calculated by multiplying numerical scores assigned to factors like the likelihood of occurrence, the frequency of exposure to the hazard, the degree of possible harm, severity, and maybe the number of persons at risk.
So you end up with a number, like 400.
Right. And that calculation is powerful because it forces a move away from subjective fear or guesswork. It allows management to prioritize corrective actions based on a measurable numerical threat level. A risk scoring 400 needs immediate attention compared to one scoring 50.
That totally shifts the conversation, doesn't it? From this feels dangerous to this is objectively a high priority risk that we must address now.
It creates that objective framework for decision making. And that kind of high stakes quantification and control leads directly into the largest single domain on the CSP exam, advanced application of key safety concepts, weighing in at 14.69%.
Okay, 14.69%. This sounds like where the rubber meets the road. Applying all that knowledge to the most dangerous stuff.
That's exactly what it is. This domain covers the practical application of controlling hazards that have high potential for serious injury or fatality. Think electrical safety, fall protection, machine guarding, confined spaces, hazardous energy control.
Lockout tagout comes in here.
Definitely. Deep knowledge of common, high-hazard workplace situations is required. This includes the specific, detailed requirements for fall protection systems and the procedural rigor needed for lockout tagout, or LOTO. And LOTO isn't just flipping a switch off. It's a comprehensive, documented procedure to achieve a zero energy state before maintenance or service work begins, preventing catastrophic machine startup or release of stored energy.
What makes LOTO so complex?
It requires specific, documented energy control procedures for each piece of equipment, authorized employee training, the use of specific locks and tags, and crucially, annual periodic inspections of the procedures. And those inspections have to be performed by an authorized employee other than the ones actually using the procedure being inspected. It's a built-in audit mechanism to fight complacency.
Wow, that's detailed. And the depth required goes right down to the regulatory fine print, like the fall protection height differences.
Yes, absolutely. For fall protection, a classic example the CSP must know is that OSHA's general industry standards require fall protection at heights of 4 feet or more above a lower level. But the construction industry standards generally mandate it at 6 feet. Knowing that specific difference isn't just trivia, it can be the key to preventing a major citation, or far worse, a fatality on a job site.
So this domain covers those immediate physical dangers. What else is in this big 14.69% chunk?
It also covers more specialized areas. Things like facility life safety, which deals with ensuring safe egress from buildings during emergencies. Think fire codes, exit routes, occupancy limits, panic hardware on doors. Also, fleet safety principles managing the risks associated with company vehicles, covering driver training and behavior, vehicle inspection and maintenance programs, and how to effectively use modern tools like telematics systems to monitor driving habits and address issues like driver fatigue.
And other specific hazards?
Yes, managing high-temperature work, so advanced knowledge of welding, cutting, brazing hazards, hot work permit systems. Also managing environmental stressors like cold and heat stress, including recognizing the signs and symptoms of heat exhaustion versus heat stroke, which is a true medical emergency requiring immediate intervention. Handling lasers safely, it's a wide range of specific high-consequence hazards.
Okay, next up we shift towards crisis response and prevention. Emergency preparedness, fire prevention and security at 10.59%.
Right. This requires planning for the worst-case scenarios. The CSP needs to be fluent in advanced fire prevention engineering concepts. This goes beyond the ASP basics into understanding heat transfer mechanisms, radiation, convection, conduction, and how they influence fire growth and spread in different workplace environments.
Why is that important?
Because that knowledge is crucial for designing or evaluating the effectiveness of fire suppression systems, like sprinklers or specialized systems for flammable liquids or data centers. It also informs how you control heat stress hazards. Beyond fire, this domain covers developing robust crisis management plans, business continuity strategies, how do we keep operating after a disaster, and measures for workplace security, protecting assets and personnel from external threats or violence.
Okay, now shifting from visible flames to the invisible dangers. Occupational health and ergonomics weighs in at 12.05%. This sounds like the deep dive into industrial hygiene we talked about.
It absolutely is. This is where the CSP demonstrates mastery in evaluating and controlling exposures to a wide range of hazardous agents. It requires deep knowledge of toxicology, understanding not just the routes of entry, inhalation, skin absorption, ingestion, injection, but also the crucial concept of dose-response relationships.
Meaning how much exposure causes how much effect.
Exactly. The relationship between the dose of a substance and the biological effect it produces. This is fundamental to setting occupational exposure limits, OELs. The CSP also needs to evaluate and recommend controls for chemical hazards, solvents, acids, metals, physical hazards, noise, radiation, temperature extremes, biological hazards, bacteria, viruses, fungi, and ergonomic stressors.
And the actual measurement, the sampling methodology, that's highly technical too, right?
Yeah. Oh, intensely technical. The CSP needs to know how to measure what often can't be seen or smelled reliably. This means understanding detailed air sampling methodologies. For instance, knowing that filter media in a cassette are used primarily for capturing particulates like dusts, fumes, and mists, whereas sorbent tubes filled with materials like activated charcoal or silica gel are used for sampling specific gases and vapors.
And the equipment needs to be accurate.
Critically accurate. The professional must know that the air sampling pumps used to draw air through the filter or tube must be calibrated both before and after each sample is taken, using a primary standard, like a bubble burette, or a reliable secondary standard, like a calibrated rotameter. This ensures the calculated air volume is accurate, which is essential for determining the concentration. They also need familiarity with basic epidemiology, studying disease patterns in worker populations, and the principles of ventilation system design and evaluation.
The regulatory knowledge needed for occupational health seems like it would naturally spill over into protecting the external environment too.
It does, and that leads directly to the next domain, environmental management systems, which accounts for 7.38% of the CSP exam.
So focusing specifically on environmental regulations and systems.
Exactly. The CSP needs to be proficient in the complexities of major U.S. environmental regulatory structures. For example, they must understand the Toxic Substances Control Act, or TSCA. TSCA is primarily focused on regulating chemical substances before they are introduced into commerce, requiring testing and notification for new chemicals.
So TSCA is like a pre-market gatekeeper.
In essence, yes. Contrast that with the Resource Conservation and Recovery Act, or RCRA. RCRA establishes the strict cradle-to-grave rules for managing solid and hazardous wastes after they have been generated. It covers generation, transportation, treatment, storage, and disposal. The CSP also needs familiarity with laws like CERCLA, the Comprehensive Environmental Response, Compensation, and Liability Act, better known as Superfund, which addresses the cleanup of abandoned or uncontrolled hazardous waste sites. Essentially, the CSP needs to understand how to manage the entire life cycle of hazardous materials from procurement through use and final disposal in an environmentally sound manner.
Okay, we're nearing the end of the blueprint. The final two domains seem to cover the crucial soft skills and the legal ethical boundaries. Training and education at 10.18% and law and ethics at 7.33%.
Right. Training at the CSP level goes beyond just delivery. It requires understanding pedagogical theory, specifically the principles of adult learning theory, which emphasizes that adults learn best when training is relevant, problem-centered, and draws on their own experience.
So designing effective training, not just giving it.
Exactly. It involves performing a thorough training needs analysis, who needs to know what, setting clear, measurable learning objectives, selecting the optimal delivery methods, classroom, online, hands-on, blended, and crucially, evaluating the effectiveness of the training. Using tools like pre-tests, post-tests, skills demonstrations, and follow-up observations is essential to validate that knowledge was actually transferred, skills were gained, and ideally that behaviors have changed back on the job.
And finally, the foundation of compliance and professionalism, law and ethics.
This demands critical working knowledge of occupational safety and health law, primarily OSHA standards in the U.S. This includes understanding the inspection process, employer and employee rights, and the nuances of the appeals process, which often involves appearing before the Independent Occupational Safety and Health Review Commission, or OSHRC.
Knowing the rules of the game.
And the consequences. The CSP must be able to differentiate between different classifications of OSHA violations, such as a willful violation where the employer demonstrated intentional disregard for the requirements or plain indifference to employee safety, versus a serious violation where there's a substantial probability that death or serious physical harm could result from a hazard the employer knew or should have known about. And underpinning all of this, the CSP must strictly adhere to the BCSP Code of Ethics, which sets the standards for professional conduct, integrity, and responsibility to employers, clients, the public, and the profession.
Wow. Looking back over all 9 of those CSP domains, what really strikes me is how interconnected they are. You can't implement a great risk management strategy without the advanced math to quantify the risk, or the advanced occupational hygiene knowledge to identify the exposure, or the management systems thinking to make sure the controls are actually used and maintained.
That's it, exactly. The CSP truly has to be an orchestra conductor, bringing all these different instruments, science, engineering, law, management, psychology together to create a symphony of safety. Hashtag 5E. Teasing the next deep dives.
Okay, just walking through that CSP blueprint, even at this level,
Yeah.
it's clear we've only scratched the surface of the technical depth required for each domain.
Oh, absolutely. The sheer volume of material is, frankly, overwhelming, which is exactly why we decided to structure this analysis as a 3-part series. Today, we've basically laid out the map. We've established the what.
And now we need to get specific about the how and the why behind the hazards and controls.
Precisely. So for our next deep dive, we're going to focus squarely on what you might call the tangible hazards, the immediate application of physics, structural concepts, machine guarding, and the critical regulatory compliance pieces associated with them. The mechanical and technical core that directly protects the human body from immediate harm.
That's deep dive 2. What specifically will we drill into?
We'll start by getting into core mechanical and structural concepts. This means really understanding the dynamics of forces, kinetic, and potential energy, how different materials fail under stress, and even specialized topics like column buckling. You know, understanding the difference between how a short, stout column fails typically by crushing versus how a long, slender column fails usually by bending and buckling sideways. That's critical for structural safety assessment.
And welding.
Yes, we'll look at different types of welds, like butt welds versus fillet welds, common welding defects, and the associated safety hazards like fumes, radiation, fire, and electrical shock.
And crucially, you mentioned we'll tackle those high-stakes compliance areas from the blueprint directly.
Yes. We'll dive into the specific, detailed requirements for confined space entry programs. What legally defines a confined space? What makes it permit required? What are the explicit duties of the entrant, the attendant, and the entry supervisor? We'll also revisit lockout-tagout requirements, going deeper into the step-by-step procedures for isolating energy sources.
And the fall protection difference.
Absolutely. We will conclude that second deep dive by explicitly contrasting the OSHA General Industry Standard requiring fall protection at 4 feet versus the construction industry standard requiring it at 6 feet, and explore the rationale and specific applications behind those critical thresholds.
Okay, so Deep Dive 2 is very much about physical hazards and immediate controls. Then, in our third deep dive, it sounds like we shift gears pretty dramatically.
We do. We move towards the invisible hazards and the overarching management infrastructure that makes a safety program truly strategic and sustainable.
So, more industrial hygiene.
A deep dive into industrial hygiene, yes. We'll explore toxicology in much more detail, really unpacking those 4 primary routes of entry into the body and getting into the weeds of dose-response curves and how exposure limits are derived. We'll examine air sampling methodology much more closely, the specifics of pump calibration again, choosing the right sampling media, filters versus sorbent tubes, and even how to calculate time-weighted averages, especially for workers exposed to mixtures of different airborne contaminants.
And you mentioned physical hazards that aren't visible, like noise and radiation.
Exactly. We won't forget those. We'll cover specialized physical hazards like noise understanding decibels, the A weighting scale, which mimics human hearing sensitivity, how to calculate noise dose, and hearing conservation program requirements. We will also tackle ionizing radiation, demystifying the different types, the units of measurement like sieverts or REMS, understanding their specific biological effects, and the principles of time, distance, and shielding for protection.
And finally, wrapping up the third deep dive, we look at how these complex systems are managed strategically.
Right. We conclude by exploring how safety systems are designed, implemented, and measured using advanced planning and management techniques. We'll detail some comprehensive risk assessment techniques commonly used by CSPs, like failure mode and effects analysis, or FMEA, which is a bottom-up, proactive method to identify how processes or products might fail, and contrast that with fault tree analysis, which is a top-down, deductive method used to determine the root causes of an already identified failure.
And measuring success.
Crucially, yes. We will end by looking at the essential components of an effective safety management system, SMS. Things like management leadership, worker participation, hazard identification, risk management, education, and continuous improvement. And we'll really emphasize the critical importance of using leading versus lagging indicators to measure safety performance. That shift from just tracking failures, lagging indicators like injury rates, to proactively measuring prevention activities, leading indicators like training completion rates or hazard reporting rates, is fundamental to driving real sustainable safety improvement. Hashtag outro.
So if we were to synthesize everything we've established today, the Certified Safe Professional Credential, the CSP, it's really not just a piece of paper. It's tangible proof of a unique and vital ability. The ability to synthesize incredibly complex scientific, engineering, legal, and management data into a coherent strategy for managing significant organizational risk. It truly represents the highest standard of competence for protecting workers, the public, and the environment.
It paints a picture, doesn't it? A safety leader who has to be simultaneously highly technical, deeply versed in regulations, and strategically adept as a manager. They're the essential coordinator, the linchpin required to keep modern, complex industries running safely.
Absolutely. Now, maybe a final thought for you, the listener, to chew on, drawing directly from that CSP blueprint structure we just spent time reviewing. Consider those 9 advanced domains, everything from advanced sciences and math through risk management down to law and ethics. If you were tasked tomorrow with starting up a brand new high-risk operational project, which single one of those 9 domains would you argue is the most critical to audit first to ensure the overall safety and success of that project, and why that one? Your answer to that, whether you prioritize management systems or risk management fundamentals, or maybe the advanced application of controls, or even law and ethics, that choice probably tells you a lot about your own perspective on risk prioritization and where you see the biggest leverage points for safety.
That is definitely food for thought. Where do you start when everything is critical? Excellent point. Well, join us next time as we begin that deep drill down into the mechanical, structural, and regulatory core of the CSP blueprint. Thank you for tuning in to the Deep Dive.